In Unit 3, Lesson 8, we're looking at something called constant of proportionality, which will be closely related to constant rate of change. Just keep in mind that an XY relationship will only have a constant of proportionality if that XY relationship is proportional. So another way we can think of constant of proportionality is unit rate. And then there's another term that you need to be familiar with. When we have a constant of proportionality, we can describe that relationship as having something called direct variation. So when you see that term, direct variation, that implies that there is a proportional relationship and there will therefore be a constant of proportionality. So the way that we can tell that a relationship has a constant of proportionality is if it goes through the origin, which we've talked about before. XY relationships that are proportional, when graphed, will go through 0, 0. It will also have a constant rate of change, which means that when you graph it, it will form a straight line. And then the way that we determine a constant rate of change is using this relationship. So in a proportional relationship, y is always going to be equal to something times x. And in the world of constant of proportionality, we call that constant of proportionality k. That's just the accepted variable used in mathematics to represent the constant of proportionality. So when you see y equals k times x, that k is your constant of proportionality. So in order to figure out what k is equal to, if we take that same equation, y equals k times x, if I want to get the k by itself, well, to undo k times x, I would divide both sides by x. If I divide that side by x, I've got to divide that side by x. X on top cancels x on bottom. So we have y over x equals k. So the way that you would determine your constant of proportionality is to take any y value in the relationship and divide it by its partner x value. And in a proportional relationship, those will all be the same, so it doesn't matter which xy value which xy pair you use. You can just take any y value, divide it by its partner x value, and that will give you k, or your constant of proportionality. So let's look at this in the format of a table. So in this table, we're using cups as our x value and ounces as our y value. So in order for me to plug anything into this table, I need to know what the relationship is, and I can see that relationship in this row right here, where 5 cups is equal to 40 ounces. So if I want to know what my constant of proportionality is, what k is equal to y divided by x. So in this case, that's 40 divided by 5. So that's 8. And what that tells me is that to get my y values, I simply take my x values and multiply them by 8. So in the case of 1 cup, 1 times 8 is 8. So 1 cup would be 8 ounces. Now in the next row, I'm given the number of ounces instead of the number of cups, so I'll just do the reverse. I'll do 16 divided by 8, which is 2. So 2 cups is 16 ounces. If we go down to 8 cups, well, I know, again, we're just going to multiply times 8 because that's the constant of proportionality. So 8 cups would be 64 ounces. And then if I want to look at 12.5 cups, I've got a couple of options here. I could just do 12.5 times 8. That would certainly be okay. I could also think, well, 2 times 6 would give me 12. So I could do 16 times 6. And then if 1 cup is 8 ounces, then it makes sense that half a cup would be 4 ounces. So then I could just add in that extra 4. You've got lots of ways to think about that. I'll just go ahead and do 12.5 times 8. So 12.5, I'm just going to call that 12.5 times 8. 8 times 2 is 16, plus 4 is 20. 8 times 1 is 8, plus 2 is 10. And so 12.5 cups would be 100 ounces. So that shows the relationship between cups and ounces in the form of a table, and now we'll look at that as a graph. So again, you can see I've got cups on my x-axis and ounces on my y-axis. I now need to decide what I want to count by. So for cups, I'm going to just count by 2s, so that would be 0, 2, 4, 6. I'll just keep that going. And then for my ounces, well, I went all the way up to 100, so I need to count by something fairly large. Let's count by 20s. So 20, 40, 60, 80, 100, 120, 140. So I know that I'm going to have a point at, and again, I don't have to graph all 5 of these points. I really should graph a couple of them. I'm going to have a point at 216. So right 2 and up 16. So not quite to the 20, so about there. And then let's do at 864. So right 8 up 64. Right 8 up 64. So just a little bit past the 60. So about there. And then I can simply connect those, make my line. And so that line also shows the constant of proportionality as being at 8, because we could kind of zoom in right here. So if we have 0 and then 2, 1 would be about right there. And if you plot that point, you can see that that would be at about 8, because it's not quite halfway to 20. So that also shows constant of proportionality. You can just take any of your y values and divide it by your x value. Now I can also show this as an equation. So our equation would be y equals 8 times x. Your constant of proportionality is 8, so k equals 8. Your unit rate, you could express that as 8 ounces per cup. 2 other points on that line, we can use 2 that are already in our table, or we could do some others. I know that 324 will be on the line, because if x is 3, then y is 24. I know that 1080 would be on the line, because if x is 10, y is 80. So as long as I know the relationship, I mean, I can keep giving an infinite number of points that would be on that line. Let's go to the next one. So we have pounds is our x value, and we have cost in dollars. It's our y value. And the only relationship that I can see both pieces of right here is that 4 pounds is $26. So if I want to know dollars per pound, I'll do 26 divided by 4. I'll raise the decimal, drop a 0. And we get 6.5. Okay, so I know that we're talking about a relationship here of $6.50 per pound. And so I can see that right here in that top row, $6.50 would buy you 1 pound. So for 10 pounds, I want to do $6.50 times 10. I can just move the decimal one to the right. It will cost you $65. And then if I want to figure out 15.5 pounds, so 15.5 times 6.5. 5 times 5 is 25. 5 times 5 is 25 again, plus 2 is 27. 5 times 1 is 5, plus 2 is 7, and I'm done with those, and 0 over. 6 times 5 is 30. 6 times 5 is 30 again, plus 3 is 33. And then 6 times 1 is 6, plus 3 is 9. Now I have 2 digits after the decimal, so 2 after the decimal. So 15.5 pounds would cost $100.75. So now again, if I want to graph it, I've got pounds on my x-axis and dollars on my y-axis. Again, because in this case, pounds is determining the cost, so pounds has to be your x value. I'm going to go ahead and count by 2's again there. And then my dollars, getting up to be pretty big there with $100.75. I'll count by 20's again. So $20, 40, 60, 80, 100, 120, 140. And then I'll just graph a couple of those points so I can see that I've got a point at 426. So right 4 up 26, so about right there. I've got a point at 1065, so right 10 up 65, so about right there. And then I can connect those. And then that graph also represents the constant of proportionality, because again, we could zoom in. 1 would be about right there, and you can see that that's at about $6.50, not quite halfway to 20. So my equation here would be y equals 6.5 times x. My constant of proportionality is 6.5. My unit rate is $6.50 per pound. And if I want to talk about two other points that would be on the line, well, I know that if I have 2 pounds, that's going to be $13. I could do 4 pounds. Well, if 2 pounds is $13, then 4 pounds, double that would be $26. So that point would also be on the line. So that is it for constant of proportionalities. Very similar to constant rate of change, except that you're only going to have a constant of proportionality in a proportional relationship, meaning that it'll be a straight line that goes through 0, 0. And you are now ready for practice 3, 8. Have a great day.